Okay, so this will be short, but so Ula and I are sort of researchers at Norse, part of a project called Climate Futures, which I'll describe in a bit. But I thought it was interesting just to show this image. So I used the DALL-E, which is a sort of ChatGPT AI large language model to make an image of sort of climate adaptation and AI, and this is what popped out, which is very interesting, has some interesting themes. So mostly, so there's renewable energy, there's drones, there's farming a lot, and they're using lots of data. And so this is really sort of the theme for today is sort of the integration of forecast, weather data, big data, AI into climate adaptation. And so the context of this is that the world will become wetter, wilder, and warmer. And so people need to adapt. And so the main idea is that knowledge of the future is useful to adapt right now. Yeah, so Climate Futures. So we're an SFI, so a Center for Research-Driven Innovation, run out of Norse. We are our mandate basically is, or our goal is to reduce weather and climate risk using predictions. And so we heard a little bit about various sort of weather forecasting today, even out to 21 days, which is quite long. But there exists sort of a spectrum of timescales where we can predict things. So Stefan also mentioned this, but maybe for this audience it's worth mentioning again. There are many different types of forecasts on different time horizons. So there's your weather forecast on your phone. I'm not exactly sure if that's it or not, but anyways. Then there's this sort of gray zone of climate subseasonal forecasts. So anything from, say, a seasonal forecast to a couple months, to a year, to 10 years, a sort of decadal forecast, and now to sort of what we hear a lot in the media, these sort of CMIP climate projections. So if the world, the CO2 increases by a certain amount, then this will happen. Changes in temperature, rain, whatever will happen in the next decades to centuries. And so within sort of this goal, the idea here is we're collaboration between academic institutions, some of which some members are here today, but everything from the Met Office to NHO, the business school in Bergen, Norsk Regjeringssentral. So academics and public and private sector partners. And so here where Climate Futures is split into nodes. So we have resilient societies, renewable energy, smart shipping, and sustainable food. And within these are several companies and organizations. Specifically, for example, I work with Trygg Forsikring, and Ula works with Småkraft, which is a small renewable energy provider. And so the idea is to bring all these partners together and try to get them to use forecasts in a useful way. Sort of the last point about Climate Futures. So we do research as innovation, and so it's often a bit confusing, but basically, so we have our partners which are interested in products, services, and knowledge, and we have researchers which are interested in scientific papers. And so we come together by doing these pilot projects, which eventually become something good. And then maybe I'll just set the scene for Ula. So it's been mentioned before many times, but it's worth saying again that AI and weather forecasting has literally taken weather prediction by storm, so no pun intended. So essentially it's fast, cheap, and accurate. And this is extremely surprising. And from the research world, it's really changing almost everything. Yeah, and I'll give the floor to Ula. Thanks.
Yeah, thanks a lot, Etienne. Just to get back to this, there's actually a nice storm in that picture up there. So very, very timely of you, Etienne. Let me talk a bit about the potential that we see that AI could have inside Climate Futures and for its partners, especially with regards to climate adaptation. So we've mentioned some recent developments, and I would like to maybe point out a couple of other ones that I think are very interesting. So we've talked a lot about GraphCast, and I think the biggest advancements have been made lately on really optimizing these forecasts on the short timescales. And I mean, we've seen impressive results of this. As Etienne also showed, in Climate Futures, we're a bit more interested in these longer timescales. And there we have a bit different challenges that also Lonneke touched upon, actually. So for us, there are certain questions that arise related to this, and I think there's a lot of interesting developments going on. For instance, there's the sort of a spin-off of the GraphCast model, which is called GenCast, also developed by DeepMind, which is more targeted at ensemble forecasting. So basically generating these different scenarios that will actually allow us to give a lot more reliable forecasts, especially on extended range timescales. There have also been other developments, so we've already heard a bit from Thomas, I think, that this GraphCast model, for instance, at longer timescales, it tends to smooth out the forecasts, which is something that it does because it tries to optimize a certain score, which is physically relatively unrealistic. As such, running these models out longer, they don't produce a very stable climate. So there's also been other developments, for instance, neural GCM, where basically we take all of the advancements that we've made in numerical weather prediction, and we leave the dynamical core as something differentiable and a dynamical model. But all of the processes that are happening inside these grid boxes that also Stefan showed earlier, where we basically now parameterize certain processes that we can't resolve. We let these be modeled by machine learning techniques, which has also shown some promising results, and actually, especially for these longer-term predictions and projections, could be a very promising avenue. But I'd like to go a bit more into detail on Climate Futures and where we see the potential here. So one nice thing is that together with Klaas and Sabri, we've been able to get access to GraphCast now, which has been installed. So we're starting a collaboration with Nike. And so at the moment, we're generating these seasonal forecasts. And one problem that we have is that basically by the time we have processed all of the data, the forecasts are already a bit outdated. So we usually get access to them around a little bit less than 2 weeks after they've actually been generated. So it has been shown that you can actually enhance these forecasts and enhance their skill by including the observations that are available up to that point. So one idea that we have is, can we maybe enhance them even further by informing these models using another forecast model, which, as it is now with GraphCast, for instance, should be very for us to generate on the spot, which could basically inform us about which of these ensemble members that we have in these forecasts, which of these scenarios are more realistic than others, potentially. So that is one specific project that we're going to look into in the future. Then another thing that is probably quite obvious in a way is that from what Etienne said at least, is that we're mostly interested in the impacts here, right? We want to really bring these forecasts or make them into information that is usable by our partners. Which is something we often call impact forecasts. So as an example, I work with a partner in hydropower. So of course, they're not necessarily interested in precipitation or temperature, which is a model output, but they want to know how much water flows down the river, or maybe even how much energy they can produce with this water. So what we do at the moment is that we take the output from these physical models, we correct them, because of course we know they have certain biases and errors. Then we pass them into another potentially nonlinear model, which again propagates all of these errors that we have, and then we try to make a forecast of the impact. So of course, one idea is to instead of doing this whole chain, basically replace this by some AI model. Another example would be from insurance, where Etienne works, where for instance, Trig, they're not interested in the precipitation or the wind, but they want to know what damages these could cause. So this is where we see a lot of the potential for AI here. Then another thing that has already been touched upon is the democratization of forecasts, and I think this comes with a couple of caveats maybe, but as it is now, all of these forecasts are run at huge centers that basically can afford to run these, and there's only a couple of those around the world, right? So we see that now with GraphCast, for instance, it's basically possible for a lot smaller entities to run these forecasts. But also, as they are now, they're fairly general, so they are not very optimized for a specific use. So I think a question here is it also possible to basically optimize or train these models a posteriori to basically make them useful for instance, for our partners or for any other user around the world. And I guess here it will probably won't happen that a company might optimize their own model, but maybe at centers such as Norse or others, it will be possible to do this and then to be sort of the middleman to deliver these forecasts to more targeted use. Another idea in this context is something that also Stefan mentioned concerning retrieval augmented generation. So of course, this is also sort of a very nice example of how these forecasts could be democratized or made more accessible in a way. Because if we manage to let a large language model interact with our forecast or basically be informed by our forecast data, a user could go in and basically retrieve understandable information from these data that would not necessarily provide on an individual basis otherwise. And I think with this I would like to end, and I hope this showed you a bit where we see the potential for AI and climate futures. Thank you.